Okay guys, so let's talk about this review. I'm just gonna go over the questions really quick. You forward it to the questions you need to see and study, or you could speed up the video too, put like a faster speed so I can talk faster, or slow it down, whatever. All right, so for number one, this is coordinate notation, okay? And you should be able to recognize that this is a translation. They're asking you to move it 7 to the right, so it means all these coordinates are going to move 7 to the right and down 9. And then that's where your new trapezoid is going to be. Okay, so let's do that. You can either count, count 1 by 1, 1, 2, 3, 4, 5, 6, 7, and then down 9, or you can also just add them. So that's what I'm going to do. I'm going to take all my x's and add 7, all to the x coordinate. So negative 3 plus 7, okay, it would be 4. And then for t, 7. For u, 1 plus 7 is 8. And for v, negative 5 plus 7 is 2. Then for the y coordinate, I'm going to subtract 9 because they're all going to move down 9. So 6 minus 9 is negative 3. 7 minus 9 is negative 2. 4 minus 9 is negative 5. And 2 minus 9 is negative 7. And now you can plot your new coordinates and be done. So 4, negative 3, that's s prime. 7, negative 2, t prime. 8, negative 5. U prime, and v is 2, negative 7. Now you can connect it. And there you go. You can see that the trapezoid moves 7 to the right and down 9. And you would want to check that if you wanted to from t to t. So t, 1, 2, 3, 4, 5, 6, 7, and then down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that worked, and that works for all the coordinates. Okay, number 2, we now have a picture of the translation. Okay, we can see that this parallelogram moved to the left and down, and it's in the new spot. How do I know it started on the top right? Because we look at the letters, right? W, X, Y, Z, and then this one says W prime, so it means it moved left and down. This one says X prime, so it moved left and down. They all move the same amount because it's just a translation. So you do want to count one at least. I am going to count from W to W prime. So left, 1, 2, 3, 4. So that's 4 to the left. And down, 1, 2, 3. So in words, you're describing what happened. So it's kind of what I just wrote. I'm going to put translate because it means it slid, it moved 4 to the left and down 3. 3 down. Okay, you can write it differently, however you want to write it. As long as you're telling me which way it goes, left, right, up, down, and how much. Number 2, coordinate notation. This is coordinate notation, guys. A lot of you guys were asking me, so you need to copy something similar. Okay, that's coordinate notation. So I'm just going to write what's highlighted. X comma y. It means each point is going to move. It's going to translate. X. Okay, did it go right, left? It went left, so that's a minus. And it went 4 to the left. And y. And it went down 3, so that's a minus 3. And that's coordinate notation. Vector component form is written in a different way, writing this in a different way. Vector component form is when we have those straight brackets. And again, the first number should be right or left. So we went left 4, negative 4, and down 3, negative 3. Okay, all these are saying the same thing. This says the same thing. Coordinate notation says the same thing. Vector component form says the same thing. But they're just different ways to say it. We say it in words, we say it in coordinate notation, and we say it in vector component form. All right, number 3, you are supposed to name the vector and give its direction. So name it. Is it BC or CB? Because the name matters. And it starts from the segment to the arrow. So this arrow is going right. It points to the right, and then it turned down, right? So it's going right and down. So it does start at B. So the name of this vector is BC. Vector BC has a direction of 2 to the right, because we always go right and left first. 1, 2. 2 to the right, that's positive 2. And then it went down to negative 2. And that's finished. Okay, second one. This one is BA. This one's called vector BA because it starts from the point to the arrow. And this one went left, 1, 2, 3, 4, 5. So that's -5 because it went left, and up 1, +1. Okay, reflect the triangle over the x-axis and then over the y-axis. So I wanted you guys to see both. First, over the x-axis. Okay, if we reflect over the x-axis, that means, here's my x-axis. So that means that the shape is going to go from the top to the bottom. Okay, I should know that it's going to go from the top to the bottom. So what you want to do is you want to count, okay, how far is C to the line? 2. So now you do the same amount on the bottom. 1, 2. That's C prime. A is 1, 2, 3. Count to the line. That's going to be 7. So now you're going to do 7 underneath A prime. And B, how far does it take to go to the line of reflection? 6. So now I do 6 underneath B prime. This would be my answer for the x-axis. If then you're going to reflect it over the y-axis, honestly, I don't really mind which answer you guys give me. If you guys reflect this one over the y, then it'll go to this side. Or if you guys actually did the image over to the y, then you would get that answer. I probably didn't give very straight directions, so whichever one you did, it's fine. But make sure that, you did the reflection correctly. So I think I'm probably going to go back to the original. So I'm going to reflect this one over the y. Or, I don't know, what did you guys do? Let's see. Yeah. Okay, you guys did the image, or somebody did, so I'll just do that one. So we're going to take now from the x-axis over to the y-axis. So now we're going to fold it over the y. So if we fold it over the y-axis now, it means that now you want to count from C to the line. So it's going to be 1, 2, 3. 3 to the left. So now you start at the line and you go 1, 2, 3. And that's where C double prime is. B is going to be how far to the line. That's 6. So now we're going to do 6 on the left side of the line. B prime. And A is 4. So now we're going to do 4 on the left side. Double prime, double prime. Again, if you did the top triangle, that's okay too. It's fine. I didn't give you clear directions on which one you were reflecting over the y. So if you went back to the original, that's fine. But you should have something like this, right? The most important part here to understand is that they are the same distance to the line of reflection. C was 2, now it's 2 below. C was 3 to the left, now it's 3 to the left of the line, right? They're the same distance to the lines of reflection because they should be equal. They should be even. Okay, number 5. We are reflecting the points over the line. This is a line. Don't forget, that's a line. So if I go, so I would use the calculator to type that line if I don't know what it is. Right now I can only show you with decimals because I don't have a calculator. Y equals X, that is a line. It's a diagonal line, right? It's a diagonal line. And it's called y equals x. Why? Because it's at all the points where y equals x. It's at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. And then it does the same thing backwards. -1 with -1, -2 with -2, -3, so on. So let's come back. So first I'm going to draw that line. I'm going to do a couple points. 1, 1, 2, 2, 3, 3, 4, 5, 6. Now I'm going to go backwards. I'm going to grab my ruler and connect those dots. Done. And now we are reflecting the points M and D over the line. Okay, if I fold the paper diagonally, it means D should move from here to somewhere on this side. The answer should be somewhere around there. And M is going to move all the way somewhere over here, because they should be the same distance to the line. So if D is this far to the line, then I should get it somewhere on this side. And M should be somewhere like over here. Okay, that's my best guess, an estimate. So if my answers end up really weird, then I know I did something wrong. On this one, you can count. Okay, you can count. So it depends on how you guys like to count. You can count left until you hit the line, but then you got to switch direction, count up. Okay, that's one way to count. Or you can count up and then count left. So I'll probably count up 1, 2, 3, 4. So now I gotta go left 4. 1, 2, 3, 4. And that's D prime. It's at 1, 5. And it used to be at 5, 1. So maybe you guys can already see the pattern. Every single time you guys reflect over y equals x, the numbers just switch. Okay, here, if I count left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It took me 13. Then I'm going to count up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, this is M prime. And again, first the coordinate was 7, negative 6, and now it's negative 6, 7. So again, all they do is switch when you reflect on y equals x. So you also want to take some time to like think about what happens. So then if I asked you guys to reflect a whole shape, and you have to reflect 5 points, then you can understand the pattern and then you won't have to do all that counting. Okay, now you are reflecting these 2 points over the line y equals negative x. So it is a different line. So what does a negative x look like? Just going to be the diagonal in the opposite direction. There it is. Okay, it's where x is positive and the other one's negative. Like here, negative 1, positive 1, or negative 2, positive 2, or down here, 1, negative 1. So same numbers, but diagonal in the opposite direction. So first you want to draw your line. 7 with negative 7, here, here. Negative 3, 3, negative 2, 2, 0, 0, 1, negative 1, 2, negative 2. Okay, it goes this way. So now I'm going to connect it. Looks good. And again, you can count on these because the slope is 1. So I would count to the left, 1, 2, 3, 4, 5, 6. And now I got to count down. Okay, you wouldn't count up. That doesn't make sense because if you count up, you're going to stay on the same side of the line. We don't want to do that. The C is supposed to go from being on the top to now being on the bottom. So you're counting left to the line and now down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's C prime. T, I can count up and then right, or I can count right and then up. Same place. You'll end up in the same spot. Because now it's going from the bottom to the top. So you do want to switch to counting up at some point. And it's going from the left to the right. Okay? So anyways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's where T prime would be. And think about what happened with the coordinates, okay? C was at negative 2, 8. Now C prime is at negative 8, 2. Okay, again, they just switched. But they also switched positive and negative sign, right? The 8's now negative and the 2's positive. For T prime, it's now at 4, 6. So they switched spots and they both switched signs, positive signs. So this row means it's negative y, negative x. They switch places and they both become positive or negative. Okay, number 7. Okay, number 7. We cannot count on number 7 because the slope of the line is not 1. Okay, what is the slope of this line? Again, the line goes left to right, so you can count it is moving up. So you just want to pick some points and study them. So looking here, it goes up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. So that means that the slope is 1/3. And you should be able to tell from here, it's going up 1 and over 3. So now what we want to do is we want to make a perpendicular slope, because that's what's happening with all of these. If I make a line connecting D and D prime, and I make a line connecting M and M prime, those red lines are going in the complete opposite direction of the black one. Okay, the black one is moving up. It's going up 1 over 1, up 1 over 1. When you move right to left, up 1 over 1, up 1 over 1. But the red lines are moving in the opposite direction. They are going down 1 over 1, down 1 over 1, down 1 over 1, right? Because they go left to right. So they're doing the opposite. Okay, here we need to do the opposite, the perpendicular slope. Okay, perpendicular means if it was positive, now we're going to have a negative slope. And if it was 1/3, now we're going to have 3 over 1. So you want to change it from positive to negative. And if it was 1/3, change it to flip the numbers, the reciprocal, 3 over 1. So now what you're going to do is you're going to take all these coordinates. I am going to name them A, B, C, and D. So then I can see where they move to. And I'm just going to go down 3 and over 1. So I'm going to start at A. Okay, down 3. 1, 2, 3 over 1. That's once. 1, 2, 3 over 1 twice. You see how it took me 2 times to do that? I need to repeat the pattern twice on the other side of the line. 1, 2, 3 over 1 once. 1, 2, 3 over 1 twice. Okay, that is A prime. Okay, let's do B. I think I am going to erase those dots that I had though. Okay, B. Down 3, 1, 2, 3 over 1. That's once. 1, 2, 3 over 1 twice. Now, it's not going to do a full 1. So I'm not going to count it until I'm over the line. But I do have 2 full sets, and then I'm going to go 1, 2, 3 over 1. Okay, so this one, I'm not really going to count it. It's just going to be 2 full ones, go over the line, and now I got to count 2 full ones. 1, 2, 3 over 1 once, 1, 2, 3 over 1 twice. And that is where B prime would be. Okay, hopefully that makes sense, because you should have the same amount on both sides. Okay, again, this was 1 full one, 2 full ones, and then I cross over, and then 1 full one, 2 full ones. Hopefully that makes sense. Let's do C. Okay, 1, 2, 3 over 1. That's once. And now I'm not going to count it until I get over. 1, 2, 3 over 1. Okay, so now I need to do a full 1. Okay, I did a full 1 and then I got over. So now I'm going to do a full 1. 1, 2, 3 over 1. Okay, this is C prime. Right, we did a full 1, a full slope pattern, and then we crossed over in another full slope pattern. Okay, for D, D's not even going to let you do a full 1, so it means you just have to cross over. 1, 2, 3 over 1. That's D prime. Okay, this one you didn't even get to do a full slope because it's doing half the pattern and half the pattern on the other side, right? Down 3 over 1, and that's it. And that is where your shape is. So you can connect it here, 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 and here. And if you look at it, okay, if I was to fold this paper, it should match up if I fold it on that blue line. And to me, it looks like it, right? And even if you guys did lines from D to D prime, they should be the same distance. Same distance on the top, same distance on the bottom. Okay, a line from A to A prime, it should have the same distance on the top, same distance on the bottom. They should look even. They should look pretty even. And they cross at 90-degree angles, so that's the other important part. So if I make a line from A to A prime, the red line and that blue line is crossing at 90-degree corners because they're perpendicular. Okay, let's do 8. So now rotating counterclockwise. So if you forget what counterclockwise is, do like a small clock on your paper or something. Okay, so whoops. So if the paper said 12, if the clock said 12, it's going to go to 3. This is clockwise. Okay, clockwise is turning your page to the right. That's what clockwise is. So I'm going to show you guys 2 different ways. First, I'm going to show you where you turn your paper clockwise, and then the other one with vectors. I don't think you guys are going to see the rotation because my iPad is turning and not the page, really. Okay, so anyways, we are starting from the origin. So I'm going to start at the origin. So what I'm going to do is I'm going to turn my paper 90 degrees counterclockwise. Okay, counterclockwise means to the left. So your paper needs to turn to the left. So I'm turning my computer. And then now I'm going to count from the origin to T. I'm going to call it O, so then I can give myself directions. From O to T, what do I have to do? Okay, what is that vector? It's going to go left 1 and up 1, 2, 3, 4. So -1, 4. For P, OP, how do I get to P? It's going to go left 1, 2, 3, 4, 5. So left 5 and up 6. Okay. And then for M, I have to go left 7 and up 2. So now I turn my page back to its normal starting position. I'm gonna erase those vectors, and then I'm gonna take the same directions that I'm just gonna follow the directions. It says left 1 and up 4 for T prime. Left 1 up 4. This is T prime. Okay, left 5 up 6. That is P prime, and left 7 up 2. And that's M prime. And that is where your new image would be. Because it started at the origin, there is a pattern. If you kind of analyze 2 of the coordinates, you should be able to notice it. M was at 2, 7. But now M prime is at -7, 2. So what happened is they switched. So it turned to YX, and the 7 became negative. So it's negative Y comma X. So if you guys did pull up the rule, this is the rule. I'm going to show you how to do that with vectors now. So I am going to start the problem over. If you understood that, then just, you can move on to the next question. But I'm going to show with vectors how we get the same exact answer with only moving the vectors. So this time, your paper's not going to move. The vectors will move. So the way that you do it without turning your page is you take vectors from O to M, but your paper stays in its normal position, like you keep your paper straight. So this is 2 to the right and up 7. So that's 2, 7. Now P, so from the origin to P, it's 6 to the right and up 5. And T, it's 4 to the right and up 1. Again, I did not turn my paper. This is when you don't turn your paper, when you don't want to turn your paper and you just want to leave it in its normal position. So now what happens is those vectors, the vector from O to M, the vector from O to T, and the vector from O to P. Okay, those vectors are the vectors that are going to rotate. Only the arrows are going to turn. So if those arrows are going to turn 90 degrees, it means that like the vector for M, its new vector would be somewhere over here because it needs to make a 90-degree angle. So this vector is the one that's turning back 90. Okay, vector P would turn back 90 to make a 90-degree angle. And then you would know where P prime is. So P should end up somewhere like this, where it makes a 90-degree. And then same thing for T. So what happens is if you guys are doing the rule applies to the vectors now. Okay, so my new vectors are, I'm going to switch them. So, and the Y becomes negative. So -7, 2. Okay, I'm going to switch them. -5, 6. Okay, I switch them. And so -1, 4. I switch them and the Y becomes negative. So now you take your new directions. You leave your paper still straight. So now you're going to go left 7 from the origin and up 2. This is M prime. And again, if you make a vector from O to M, you can see how it did a 90-degree angle. Then -5 up 6, P prime. And for T, left 1 and up 4. So the vectors are the ones that are turning. See how it makes a 90-degree angle from T to T prime. But yeah, so you get the same answer, okay, if you want to rotate the vectors or you actually want to rotate your paper, whichever one you do, you get the same answer. There you go. Hopefully those two methods made sense. Okay, now we are rotating 270 degrees, but at a coordinate. Okay, so again, two different ways to do this one. You can rotate your paper, or you can rotate the vectors. Oh, it's gonna be a long video. All right, so I am gonna mark my point of rotation, which is 3, -4. We're gonna call it M. I'm gonna turn into a little star so I don't get it confused. And now, again, clockwise would mean you turn your paper to the right. And 270 is 3 times, but counterclockwise is back to the left 3 times. So right now my paper's in its, normal position. Now I'm gonna turn it back. So it's 90, 180, and 270. So that means that the shape ended up where like Q is at the top and S is on the bottom now. So Q's closest to the top and S is on the bottom. And now I'm going to take directions. Okay, from M to Q. What do I need to do? I need to go right 1, 2, 3, 4, 5. I need to go right 5 and I don't go up and down, so that's 0. Okay, to get to R, I go right 5, 6. Right 6 and down 2, -2. This vector is going to go right 6 and down 2 to get to R. To get to T, MT, I would go right 1 but down 1. And to get to S, I would go right 1, 2, 3, 4. And down 1, 2, 3, 4, 5, 6, 7, -7. So now I flip my paper back to its normal starting position. And then I follow those same directions from M. So from M, go 5 to the right. 1, 2, 3, 4, 5. And this is Q prime. Okay, from M, go 6 to the right and down 2. That's R prime. From M, go 1 to the right and down 1. That's T prime. And from M, for S, you go 4 to the right, 1, 2, 3, 4, and down 7. 1, 2, 3, 4, 5, 6, 7. And that's S prime. And that is the answer to my new shape. It rotated 270 degrees counterclockwise around M. So it went back all the way, or you could have just gone forward. But it's basically like these circles that are being created, and then they are creating this cross section of 90 degrees. Okay, so here's 90, and here's another 90. So what happens is when I say move T 90 degrees counterclockwise, it would move to this section. And then 180, it would move right there. And then 270, that's why it ended up there. So that's kind of what delta math makes you guys do. It makes you guys draw a circle, make a line, make a perpendicular line so you get those 90-degree corners. And you can even see it with bigger circles. So if I made a circle from Q to Q, okay, it's not the best because it's kind of hard. There you go. But again, if you make a line from Q to the M, and then you would need a perpendicular one. And it's not perfect, definitely doesn't look great. It's kind of off a little bit. but it just goes around the circle. Okay, I'm gonna show it one more time with vectors. Those of you that kind of know how to do it with vectors. Okay, let's do it with vectors. So one thing about the vectors, if you are gonna do it with vectors, you need to know the rule already. So I don't even remember the rule. Okay, anyways, 270 degrees counterclockwise means that the rule is y negative x. There you go. Okay, so what we have to do is now we have to start at our center of rotation, which is 3, -4, m, and you make a vector. You don't turn your paper. If you're doing it with vectors, you don't turn your paper. You're just making the directions from m already. So from m to t. That would be 1 to the right and 1 up. So it's 1, 1. From M to S, that is 1, 2, 3, 4, 5, 6, 7. 7 to the right. And up 1, 2, 3, 4. From M to Q, that is just up 5. So that's 0, 5. Right? It didn't go up or down from M. It just went up 5. 1, 2, 3, 4, 5. And then for R, you go 2 to the right, and then you go up 6. So when I now have all my directions to the coordinates, and I didn't turn my paper. This is when you guys do it with vectors without turning your page, which is fine. So now you have to apply the rule to the vectors. This rule has to apply to these vectors, and you take your new directions. So then we are going to switch them, and the x becomes negative. Okay, that's what the rule says. So my new vector is going to be, I don't know where to write it. I'm going to write it on this side because I don't have space. Or, okay, m to t prime. Okay, new vector. You switch them, so it's still 1, 1 because they switch, but the x becomes negative, right? It's the back point number now because x moved to the back. Now ms, the vector for ms prime is now 4, -7. Okay, vector for q, mq. So from m, we're starting always from m, then it's going to turn into 5, 0. The 0 becomes negative, but it's 0, so I'm going to leave it. And now from m to r, it turns into 6, -2. So what you do is you now make these vectors go from M. So now you're going to follow the directions from M. So from M, go right 1 and down 1. Right 1, down 1. That's where T prime is. For S, I'm going to go right 4. 1, 2, 3, 4, and down 7. 1, 2, 3, 4, 5, 6, 7. And that's S prime. For Q, 5 to the right, 1, 2, 3, 4, 5. Q prime. 1, 2, 3, 4, 5, okay. And then for R, 6 to the right and down 2. So we end up with the same exact answer, but I showed you 2 different ways. One of them, you turn your paper, even though I don't think you guys saw me turn my computer, but I did. I turned it, and then I did my directions. Then I turned it back, and then took the same directions. For the one with vectors, you take your vectors, you don't turn your paper, then you gotta change the vectors based on the rule, and then you gotta follow those vectors back to your new points. Okay, finally done with all those rotations. So that was 8, 9. Okay, this is question 8, 9. We're on 10. Okay, dilating it from the origin. When it says from the origin, this one's easy. All you have to do is multiply all the points by 3/4. When it says from the origin, yes, you can multiply everything by 3/4. If it doesn't say from the origin, then it's a lot harder. You got to do vectors and then multiply the vectors. Okay, so if I'm going to multiply everything by 3/4, that means you multiply by 3 and divide by 4. Or you can use the calculator if you want to do it that way. So for L prime, I'm just going to write the answer right above it. -12 times 3 is -36, divided by 4 is -9. and 0 times 3 is 0, divided by 4 is still 0. Okay, so that's my new L prime. For M, multiply it by 3, negative 12. So negative 4 times 3 is negative 12, divided by 4 is negative 3. Yep. Okay, negative 4 times 3 is negative 12, divided by 4, negative 3. For N, negative 4 times 3 is negative 12, divided by 4 is negative 3. Negative 8 times 3 is negative 24, divided by 4 is 3. Or no. Okay, negative 8 times 3 is negative 24. Oh no, that's 6. Okay. Negative 8 times 3 is negative 24, divided by 4 is negative 6. And then for, oh, we just have to do 12. Okay, but we already know the answer is negative 9 because I already did it here. But anyways, I'll just do it once more. Negative 12 times 3 is negative 36, divided by 4 is negative 9. So you get negative 9 twice for O prime. So now you want to plot them, and then you'll be done. Okay, negative 9, 0. Negative 9, 0, that's L prime. And then M is negative 3, negative 3. N is negative 3, negative 6. And O is negative 12, 0. No, negative 9, negative 9. Hopefully you guys are kind of seeing that what's happening here is they're making vectors from the origin because it is growing from the origin. So from the origin to L, it was really long, and now it shrunk back. Okay, this vector is shrinking back to 3/4. So if you took the original vector and you cut it into 4 slices, so here, here, and here, now it's only using 3 of them. That's why L moved back. Okay, L had to get, it got shorter. Okay, now for O, it was this long, now it got pulled back 3/4. For M, it was here, now it got pulled back. For N, it was here, now it got pulled back. Okay, the vectors are the ones that are shortening by 1/3. Or 1/4, I mean. All right, last two. For these, even though they don't have a graph, obviously when you guys are preparing for testing at ACT, if they don't give you a graph because they don't give you graph paper a lot of time, you can make your own graph paper. Or if there is another problem that has graph paper, feel free to use it. Like for me, I would probably use, I don't know, some blank graph paper that I see. But if not, I make my own. So even though it doesn't have a graph, you can still use it, okay? And so you can think through the process. Okay, so if we're at 6-5, so I'm gonna make graph paper for myself. And it's just a sketch, it doesn't have to be perfect. 1, 2, 3, 4, 5, 6. 6 to the right and up 5. 1, 2, 3, 4, 5. So it means that we are about here for K prime. If it says it reflected over the line y equals 2, hopefully you understand what that line looks like. But it is up 2, and it is a horizontal line. So now if it reflects over that line, it means that it went from here to the bottom. Right? Or technically it started on the bottom, K, and then when it reflected, it moved to the top. Same thing. So now you just kind of got to think about it, like, where is it going to go? It's going to go right underneath it. And you kind of got to count. So if you're already at 5, okay, we're at step 5, we're up here at level 5. How am I going to get to 2? Well, you're going to count down 3. 1, 2, 3, and you hit the line. So now you got to go 3 underneath. 1, 2, 3. This is where K is, and that's 6, -1. And the reason why that is the X should still be the same answer because it's still 6 to the right and up 5, and now it's 6 to the right and down to -1. And why is that? Again, because from 5, if you were already at 5 and you're trying to get to 2, it subtracted 3. So then from 2, you subtract 3 and you would go down to -1, or just however you need to process it, right? Or you can even think about it another way. If you take the line of reflection, 2, how do you get to 5? Well, yeah, you would add 3, but then if you're going to go under, then you would subtract 3 to get to the other coordinate, because it should be the same distance. So from the line, if you go up 3, now from the line, you got to go down 3. And it's still 6 to the right. So that's your coordinate for K. K is 6, -1. Oh, last one. Okay, this is dilation, so multiplication. If we know that P, we don't know P. We don't know the original coordinate. But I do know that P prime is -2, 5. And I know that I was supposed to multiply them by 1/3. Okay, so it means that whatever this number is, once I multiply it by 1/3, it turns to -2. And multiplying by third is technically dividing by 3. So if you divide a number by 3, it turns into -2. And for the y coordinate, same thing. If you divide it by 3, it turns into 5. So anyways, when you're going backward, when you know the final result and you're going backwards, it's the opposite. So instead of multiplying, you want to, instead of dividing by 3, you want to multiply by 3 or so on. So here, I am going to multiply these by 3, and I get -6, and I get 15. And I want to check them though. I want to pause and check. Okay, so if it is -6 and it is 15, if they tell me the scale factor is 1/3, so I multiply it by 1/3, and I multiply it by 1/3, right? Because that's the original coordinate, then -6 times 1 is -6, and divided by 3, I get -2. 15 times 1 is 15, divided by 3 is 5. So is that what happened? Yeah, we had to start with these numbers to then end up with -2, 5 when we multiply by 1/3. So going backwards, or going forward, you divide by 3, but going backwards, you multiply by 3. Okay, hopefully this helped.